Hey there, welcome back. In this video, we're going to talk about P-series. So to get us started, I'd like you to consider the following four series: 1 over n, 1 over n squared, and 1 over n to the 1/2, and 1 over n to the 6th. Okay. These four series are pretty similar, right? All that's really changing is the exponent on n, the power, if you will. Okay. They all have the same basic structure. They only differ in power. Okay, they all look like 1 over n to the p. Okay, p for power. Okay, we call these series P-series. And this one I've got p equals 1, p equals 2 in the second, p equals 1/2 in the third, and p equals 6 in the fourth. The p-test is a test for convergence that tells us how to figure out whether or not these series converge. What the p-test says is that this series, 1 over n to the p, that will converge so long as the power on n is greater than 1. Okay? If the power on n is less than or equal to 1, then that series is going to diverge. Okay? So the series 1 over n to the p converges if p is greater than 1, and diverges if p is less than or equal to 1. Let's go ahead and apply this to our four series up here. So I've got series 1, 2, 3, and 4. This first series, okay, series number 1. Series number 1, that's going to diverge by the p-test because p is equal to 1. Okay, and the p-test says that if p is less than or equal 1, my series diverges. Well, I've got p equal to 1, so that series diverges. The second series, series number 2, is going to converge by the p-test because p is equal to 2. And 2 is certainly greater than 1. Okay? And if my power is greater than 1, my series converges. My third series, this is also going to diverge by the p-test because it's got p equals 1/2. Okay? If p is less than or equal to 1, it diverges. 1/2, definitely less than 1. Lastly, my fourth series here. Series number 4 is going to converge by the p-test because my power, p, is equal to 6. Okay? The series converges when p is greater than 1. 6 is definitely greater than 1, so series number 4 is going to converge by the p-test. Some important takeaways from this video. First one has to do with this series right here, this sum from n equals 1 to infinity of 1 over n. That series has a very important name. That's called the Harmonic Series. Okay, the Harmonic Series. And what do we know about this series? Well, it's a p-series. Okay, we've got p equal to 1. So that means it diverges. Okay, the Harmonic Series diverges. Very important to remember. It's important to remember because if you identify a series as being the Harmonic Series, you can say that it diverges with no further explanation or justification. Okay, you can say, hey, this is the Harmonic Series diverges. For example, you might see the series 1 plus 1/2 plus 1/3 plus 1/4, so on and so forth. That series diverges because it is the Harmonic Series. Okay, that's all you need to say. The p-test does not apply to series that look like this. Okay, if I've got 1 over 2n plus 5, or n squared minus 17, or n squared plus 2, okay, those are not p-series. Okay, a p-series, very simple, looks like 1 over n to the p. Okay, 1 over n to the p, that's a p-series. Okay, the stuff that we looked at here, okay, these series, these are not p-series. Okay, so you cannot use the p-test on them because they are not p-series. One last little takeaway. This is really an algebra thing. Remember how roots become exponents? If I've got like 1 over the square root of n, okay, remember that square root is really the same as 1/2 power. Okay? And if I've got something like cube root is really the same as 1/3 power. So with both of these, I can apply the p-test. Okay, this first one, this is going to diverge because square root, well, that's 1/2 power, and 1/2 is less than 1, so that diverges by the p-test. And the same thing for this other one. Okay, cube root, 1/3 power, that's going to diverge, okay, because my power is 1/3, and 1/3 is less than 1. Alright, that's it for p-series and the p-test. I hope you found this video helpful, and that's a wrap.